So today we will work on a 3-variable KMap. So I'm just writing out a function of ABC is equal to the sum of minterms 0, 2, 3, 5, and 7. So the first thing you want to do is figure out how many variables you have, and you have 3 variables here, which means you will need 2 to the power 3, which is 8 cells. So 2 to the power number of variables is equal to the number of cells in your map. So we're just going to draw an 8-variable KMap here. And we'll start with AB on the top and C on the bottom. And then we'll start filling in the cells. So we'll first look at the minterms. And we'll look at minterm 0. And 0 is the binary 0, 0, 0. So we'll look at the cell. And we'll look at the cell where AB is 0, 0. And C is 0, which is the first cell. And then we enter a 1 in there. We entered the 1 because the function is the sum of minterms. If it were a product of max terms, we would have entered the 0 in that cell. Next one is 2, so it's 0, 1, 0. And we'll enter it in 0, 1, 0 cell. And we do the same with 3. We write it out in binary, and then we enter it into the appropriate cell. And then the next minterm is 5, which is 101, so we'll enter it in cell 101. And then the last one is 7, which is 111, we'll enter it in cell 111. And then we'll fill the rest of the map with zeros. Then we'll start thinking about how we're going to start grouping this. So the key is the more the merrier. So the more ones I can group together, the better. And they're always grouped in powers of 2. It's always a good idea to color code your groupings. So I would use a different color code for each different group to help me identify which group I'm actually creating at that point. So we are going to look at the first 2, which is the first top 2 cells, group them in red, and then we're going to change the color, and then group the second 2. And then that last one can be grouped in 2 ways. It could be grouped with the one next to it, or grouped with the one above it. So that means we can have 2 distinct solutions for this problem. So we're going to choose a color, and then we're going to group that one with the one above it. And then we're going to start creating our product terms. So we're going to say function of ABC is equal to, and we're going to do the blue group first. So we go to the top, and we look at A and B. And then we see for both cells, is the variable A or B changing or staying the same? So for any cells within the group I'm making, are A, B, C changing or staying the same? If they're changing, I throw it out. If they're staying the same, I keep. So if I'm looking at A stays at 0 and B stays at 1. So I'm actually going to have A bar B for that term. And then I look to the side and I see that C is changing, so I'm going to throw it out. So I'm not going to be using C. Because C, if you look at it, 0 goes from 0 to 1 across the 2 cells. So it's changing, I throw it out. And then I start looking at my second term. So now we'll look at our green group, and we'll look to the top and look at AB. And we'll see A is staying constant for both cells at 1, so we'll take it as an A. And then we look at B, and B is changing between the 2 cells. It goes from 1 to 0, so we throw it out. Then we're going to look at C, and C is constant at 1 across both cells, so we're going to put it down as a C. Then we'll just change the color to red so we can get our last group. Again, we'll look at the top, and A is constant at 0, so we'll put it down as A bar. B changes, so we'll throw it out, and C stays constant at 0, so we'll put it down as C bar. And that is then the final answer. That is the most minimal solution. Again, you could have grouped a different grouping, and that grouping would have provided us, which is the yellow group, and that would have provided us with a second solution to this problem. And for that solution, we would continue the first, instead of A bar B, we would have actually looked at the yellow group, and that would have been BC. So everything else would have been the same in the expression. The only difference would be that instead of A bar B, we would have BC as the first term. And that concludes the 3-variable KMap problem.